Good morning, class. So today we're looking at differential calculus. At this point you have indicated that you had no problems with the homework. Is that correct? Yes, okay. So at this point, for some reason or other, this computer has wiped all the, what's the name, that are cut out. I just hope that didn't cut out what we're going to need to look at now. Okay. So at this point, we have worked out a few sums or examples using first principles. Okay? This is the first one that we worked out. Let's go back in your books. That's the first one. I'm going to write it down now. No? That's number one. Then this is number two, correct? Then we have number three. Example 4. I think there were 4 examples, no? Yes. Yeah. Now we're looking at examples for exercise 6. Examples for exercise 6. And exercise 6 on page 155. So some cancers need to draw your attention to quickly. Okay. Let us see, I hope this thing didn't wipe everything. Okay, see, that seems to be so those 4 examples that I've highlighted now earlier on. The first sum was, let's pull this down. What was the first sum? F of x. This was from the examples. No? F of x is equal to 2x squared minus 3x minus 5. Now in the second example, was g of x is what? Sorry? Negative x cubed. The third one, well, g of x equal to 5, is that correct? Yes. And then number 4th one was, sorry? Y f of x, eh? Yes. Alright. So looking at the first one, when you applied the first principle, derivatives using first principles. Okay? What was the answer here? You had 4x minus 3. Alright. You all agree with that one? This one here was negative 3x squared. This was 0. And this was negative 2 over. Do you see a link that's existing between the function and its derivative? Again, what is the derivative? The derivative is the general gradient anywhere along the curve. Not so. Gradient f prime x or g prime x is the general gradient anywhere along the curve. When we do the substitution at a specific point, at say for instance x is equal to 1, that will be the gradient of the tangent to the curve at 1. Okay. Do you see a link between the first and the second, or the function and its derivative? You see a link? What do you notice here? Let me see the link. Okay, we don't have all the time to You're drawing suspense here. But what you should see is 2 times 2. What's 2 times 2? 4. And a minus 1 from it. And again? 1. Did you see that? And here's a 1 here. What's 1 times 3? 3. Minus 1. So that will give you x to the 0. Not so. And then if here's x to the 0, anything to the power of 0 is 1. What's 0 times minus 5? Minus 5. Well, minus 1. And what's minus 5 times 0? 0. And minus 1. So what now happens is that is 4x. That anything to the power of 0 is 1. And 0 times anything is gone. You see that, people? What do you notice about this here? What's 3 times negative 1? Negative 3. Minus 1? 2. You see that? Look at the next one. This is x to the 0. No? What's 0 times 5? 0x minus 1. Anything to the power of 0 is? So how are we going to get from there to this? We bring that up. It becomes f of x is now equal to 2x minus 1. So what we do is we multiply that 2 by the negative 1, gives you negative 2x minus 2. That's naturally over 1. We bring that down, becomes negative 2 over 1. You guys understand? So if the question says determine the derivative of f of x by using definition, then we must do first principles. Or the question says first principles, then you must go through that whole substitution into the formula, which is the limit as h approaches 0 of f of x plus h minus f of x over h. You understand? If it says first principles, or it says by definition. If it doesn't specify, then we use this method. Can you see this from there to there is one step? You get that answer there. You understand? So if the question says by definition of first principle, the sum is worth 5, a minimum of 5 marks. Okay? So if the question says by definition of first principle, and you do this, how many marks out of 5 you think you're going to get? Not 1, you get 0. No marks. Okay? Because you're not adhering to the instruction. Okay? But again, if this is also, if they say by using rules of differentiation, then this is what you do. Or they don't say anything, then this is what you do. You guys understand? Right, now with that in mind, just something to remember is that if in general terms, if you got y equals ax to the exponent in general now, this is the general format. If that is given, what do? We take that exponent, we multiply that by the coefficient and a minus 1. Not so? That's what I did throughout. You all agree with that? So, when we apply the derivative, we call this the derivative of y with respect to x. So if here was an s and a t, then it would have been the derivative of t with respect to s. Can you see that? If there's a p and a q, then it would have been dp over dt. Okay, but we'll highlight that in the next section as well. So n multiplied by a is na or an, x to the n minus 1. That is the general format of what we're going to look at now. What do you notice here? The derivative with regards to a constant. Was there any remnants there in your answer here? No. So that means to say the derivative of a constant is always 0 there. Can you see the derivative there was 5? It's only 5. So the answer was 0. You can make a note there as well. The derivative of a constant will always be 0. And again, we need to get the expression in the form of ax to the exponent n. That must be the format of the sum. Like if you look here, was that in that format? 2 over x. Was 2 over x in this format? Huh? No. So in other words, we had to first get it in that format. This format here. Can you see that? Before I could have applied the rule, which is multiplying the exponent by the coefficient and minus 1 on the exponent. Do you guys understand? So again, this must, so that is how the expression must be, the format of it. Okay. So today we're going to look at the specific rule for differentiation. Right. So this is exactly what I tried to explain to you now. Let's see what they say. Okay. The formula for the differentiation for the function f of x is equal to a, x to the n is given by f prime x is equal to a n x to the n minus 1, for n is an element of real number. Okay. There are many rules for differentiation, but you are required to use only one. Okay. You can only use f prime x equals a n x to the exponent n minus 1 to differentiate functions if you can express each term in the function in the form of ax to the exponent n. That's what that is wrote down. It is therefore often necessary to write terms in the correct format before you can apply the formula. Okay, as we did in number 4. We have to first get it in that format. It is therefore often necessary to, right, let's just read that now. You can denote derivatives in different ways. So make sure you know how to recognize and work with each. What they are referring to there is that if you got f of x, you must write f dash x. If you got g of x, you must write g dash x. If you got y is equal to something with the x, then you must have dy dx. Or dy over dx. You understand? That's basically what they're saying there. Alright. So this is the original expression. The question says, find the derivative. Now the question that we are asking ourselves, is that in the format where we can actually apply the derivative? No. We must get it term by term. So what's the first thing we're going to do here? Multiply the bracket here. Not so. So f of x is equal to 8x squared. What's 2x times 1? 2x. What's negative 3 times 4x? Negative 12x. What is negative 3 times negative 1? Negative 3. Are they like terms? Yes. So it's going to be 8x squared minus 10x minus 3. Can I apply the derivative now? Isn't all the terms in the form of ax to the exponent n? Yes. Did you see that? So what do I write here? Once you apply the derivative, I write f prime x. So do that step for me quickly before I write it on the board. Alright, so what do we get? 16x minus 10. And remember the derivative of constant is 0. For those of you who don't see it yet, 2 times 8 is 16 minus 1. 2 minus 1 is 1. This is 1d. 1 times 10 is 10 minus 1. So it's x to the 0. Into the power 0 is 1. The derivative of constant is 0. You guys understand? Let's look at the next one. Y is equal to 3 of x. Y is equal to 3 of x. Is that in the form of ax to the exponent n? No. So what do we have to do first? Get it in that form. Bring the denominator up. So bring the denominator up. What do we get? Y is equal to? Alright. Now you apply the derivative on that expression. Remember, when you apply the derivative, we indicate the change. If it's f of x, f prime x. If it's g of x, g prime x. Okay. We indicate it once we apply the derivative. Okay. Are you? You okay? Alright. Let's take this up. What do we get? Y is equal to 3 to the negative x. We take the exponent and we multiply it by the number. So y is equal to 3 times negative 1 is negative 3x to the negative 2. Well, that's naturally over 1, not so. So where must this go? Denominator. So when I apply the derivative, I forgot to write dy over dx. If I don't write it here, I'm going to do some more. Okay? That is dy over dx is equal to negative 3 over x squared. Just in case the question says, write your answer with positive exponents. That's what you do. Okay? Any confusion there? Big D, right? What does that mean? What do you think the big D mean? Derivative. No? The derivative. So the derivative with x of the square root of x to the exponent 5. Or determine the derivative of the square root x to the exponent 5. Or square root x to the exponent 5, take the derivative thereof. Okay. People, the question you should be asking yourselves, is it in the form of a x to the exponent n? Make some? No. No, it's not. So how do I get it in that form? We're going to change it from the radical to, from the surd to exponential form. Remember that the rule that says the nth root of x to the m. This can be written as x to the m over n. Not so. So what would this be? X to the exponent 5 over 2. Now is it in that form? Yes. So apply your derivative. We're not even on the examples yet, no? We're going to make the tag now for the examples. You must pick up the pace now, no? Because lessons are short on a Friday. I don't know why. Under an iron principle. Just come in for maths and go. Don't come and waste your time. Alright. What does that mean? I'm never going to come to this book. So that idea in mind. Alright. People, so what do we do now? Multiply the exponent by the coefficient. When I apply that, what happens? Drop the D. Can you see that? We've applied the derivative. Some change has to take place when I apply the derivative. Because if I just write equal, then that means to say that that line is equal to that line, which is not the case. Can you see that? Right, so you apply the derivative, what do we get? 5 over 2x. If I minus 1 from that, I get 3 over 2. Okay, and you see the variation here. There's no y and there's no f prime x, but there's a d. Okay, which means that derivative is. Okay. Any confusion there? Nothing. Alright. The last one of this, before we go into the real examples, is this like what they call a teaser, no? Like this. For play, no? To make sure that you understand what they were saying in the introduction. People, is that d of x, or the derivative with respect to x, in the form of ax to the exponent n. Huh? Make sense? No. Not. How is it? It's a fraction. Fraction. Oh, she says no. Yes, no. Alright. So what do you think we're going to do here to get it in that form? She says. Remember, people, look at it this way. Your denominator can't contain the x. That is the crux of it. The denominator can't have the x. Okay. What are we going to do here? Yes. This. Big D, or derivative of x. Of course, they're going to factorize such that this will be able to cancel. Now what? Cancel. So d of x, the derivative with respect to x of x plus 1. Now apply the derivative. Right. So here's a 1 here, not so? And a 1 there. So I apply my derivative, I drop the d of x. Not so? So it becomes 1 times 1 is 1. The minus 1. Do x to the 0. Derivative of a constant? 0. Anything to the power 0? The answer is 1. See how easy is it, people? Right? You can understand why when somebody comes to us for tuition and the question, they're failing maths, the first thing we teach you. After solve x is calculus. It's easy. Yeah? Everybody scores well in algebra, in this section. But now don't prove me wrong, please. Because you guys are very well known. Very, very well known for this. No? We say, okay, so I said that. So let's prove him wrong. Let's just mess it up for you. Right, I think this is the last one. People, that is not the 5, that's a s. S is equal to negative 5t squared plus 3t. Apply the derivative very quickly. It's really simple. Right, so what do we write here? The derivative of s with respect to, you guys write that? Yes. Equals what? Negative 10t plus 3. You all agree with that? You don't agree? What did you get? Oh, you agree, but now why are you shaking your head that way? Okay, my glass is lying to me. No. People, let's look at the work example. This is on page. Example on page. Sorry? 154. However, the exercise on page 155. Exercise 6. People, the question says determine using rules of the. Here they're telling you to use the rules of differentiation. So am I going to apply first principles? No, there's nothing wrong with me here. Okay. F prime x, if f of x is equal to 7x squared minus 5x plus, just check it in your book, what is it? Then h over 4. The textbook, look at the textbook. Just a 4, yeah. Okay. You see, they made life easier for you guys. Okay. So let's apply the derivative. Is that in the form of ax to the power n? Yes. So let's apply the derivative. What do I write? F prime x equals 7 times 2 is 14x minus 5. The derivative of a constant is 0. Even if there had to be an h there, it will still be 0. Why? Because we're differentiating x. You guys understand? So, if they ask you to differentiate x, then all the other variables is considered as constants. You guys understand? I don't know why they actually changed it, because it would have been a nice explanation to them. But maybe it's a bit too premature, no? It's too early. Right, number 2. dy over dx. If y is equal to 3x squared minus 9x minus 2. Do the derivative there quickly. Yeah, the video is going too long, so it's going to move on. The full lessons can be found in the description box below. Right, so is that in the form of a x to the exponent n? Yes. So let's go for it. I'm applying the derivative, so I write here dy over dx equals 3 times 2 is 6x minus 1, which gives you 1. Here's a 1 here, not so. 1 times negative 9, negative 9. Minus 1 will give you x to the 0, which is 1. Derivative of a constant? You guys understand? Let's carry on with our lives. Okay, number 3. Is that in the form of ax to the exponent n? No. So what do I have to do first? Multiply. Get rid of the brackets. X times 2x. 2x squared. X times negative 1. Negative x. Negative 3 times 2x. Negative 6x. Negative 3 times negative 1. What's the 1? So I got 2x squared minus x minus 6x. Sorry? Positive 3. Nice, thank you. Minus 7x plus 3. And yeah, I thought you guys were scared of me. Not scared anymore. Taba says she's never been scared. People, is that in the form of ax to the exponent n? Yes. So I can apply, what do I write here once apply the derivative? dy over dx equal 2 times 2 is 4, x 1. There's a 1 here, not so. 1 times negative 7 is negative 7. Minus 1 is x to the 0, which is 1. Derivative of a constant? So 4x minus 7. Any confusion there? Yes? Any questions? Alright, number 4. d of x, or the derivative of x squared minus x minus 12 all over x squared plus 3x. Is that in the form of ax to the exponent n? No. So what do we have to do first? Factorize numerator and denominator here. Not so. Trinomial, so it's going to be x minus 4, x plus 3 over, what can happen in the denominator? Common factor of x, so I'm left with x plus. So what happens now? X plus 3 cancel. So what am I left with? d of x is equal to x minus 4 over. Okay. Now is that in the form of ax to the exponent n? No. So what do I do is I take each one over its own. So in other words, it's going to be d of x over x, which is 1 minus 4 over x. Can you see that? X over x is 1. Now, is that 4 over x in the form of ax to the exponent n? No. So what must I do? Bring the x up. So what do I have now? You have x of 1 minus 4x minus 1. Can you apply the derivative now? Okay. So let's go. Into b, derivative of x. Derivative of, I'm applying my derivative now, not so. So what must I do? Drop the d. Derivative of a constant? 0. What's negative 1 times negative 4? 4. X minus, well, naturally over 1, not so. Bring that down. Gives us 4 over. Easy, no? Sorry? I did that last time. Then you would have gotten a better mark for maths. But then this time you would have screwed it up completely. So then you would have worked even less this term. People, the derivative with respect to x, is that in the form of ax to the exponent n? Is that in the form of ax to the exponent n? No. So what do? I must get it in that form. So what I'm going to do is I'm going to put each one of its own. So the derivative with respect to x of x cubed over x squared, we could have just written x, minus 2x squared over x squared, or just written negative 2 plus. People, that can be written as what? X to the exponent? Oh, okay. As there's a 1 and a 2. So it's x to the half over x squared. So I'm going to simplify now. So d with respect to x. X cubed over x squared is x. That x squared is cancelled, give you a negative 2. So that's a constant. Plus. I'm bringing this up. Because if you're going to write it as 1 over x to the 3 over 2 in the denominator, then you must still bring it up anyway. Okay? Bring that up, becomes x. What's half minus 2? Negative 3 over. Now can I apply the derivative? Yes, so apply the derivative quickly. Alright, so what do we get? We will drop the derivative. So apply the derivative here is 1 and 1. 1 times 1 is 1. Minus 1 is x to the 0, which is 1. Not so. Derivative of a constant? 0. So here we got negative 3 over 2 times 1. Negative 3 over 2. X, we minus 1 from that. Negative 5 over. This could also be written as 1 and negative 3 over 2, that is in the denominator now, because I have the exponent, x 5 over 2, which also can be written as 1 minus 3 over 2 square root of x 5, or 1 minus 3 over 2 x squared root x. But if you write that there, you already get full marks. And what are we going to do? Are we going to go? No, we are already not going all the way for our normal stuff. Yeah? Last question before we leave. Number 6. So what do we have to do first? Get rid of the brackets. So s is equal to multiplying in here. So it's going to be t. We're now multiplying it by the same way. Add the exponent. So there's going to be 4 over 2, which is 2, plus 2t to the half, minus 3t 3 over 2 minus 6. Is that in the is that like terms? Huh? So we have a x to the exponent. Is that in that form? So what do I write here? Derivative of s with respect to 2 times 1 is 2. T to the 1. You all agree with that? So what is 2 times a half? 1, not so. And now minus 1, I'm going to get negative 1. What's negative 3 times 3 over 2? Negative 9 over 2t. Minus 1 is half. Derivative of a constant. If you want, you can take this further and write it with positive exponents. So it's 2t, that's equal to 2t plus 1 over t to the half minus 9 over 2t. But do we have to write it like this? Okay. People, for homework is exercise 1.55. I'm sorry, page 155. Exercise 6. Okay, you do the whole exercise for me. I'll send you a link to the video. We have done all the odd numbers in that exercise. Okay. People enjoy the rest of your day. Good morning, class. Sister.